Good afternoon. Yesterday you have discussed what are the assumptions of LVP. Like I have told you, there are 5 assumptions finite choices. So today we'll see how to how to formulate the linear programming. When a problem comes to you, how to convert it to linear form. At the same time, we'll see what are the solution methods are there. And out of this, we'll cover on today graphing methods. So as you know, let us start with first formulation. Then I'll tell you what are the methods by which the LPP can be solved. So always you have to remember there are 3 steps involved in linear programming. First is objective function. Second is subjected to constraint. It can be constrained or it can be constraints. Third is non-negative constraint or constraints. Symbolically, objective function always written as O.F. Subjected to constraint written as STC. If you have more than one constraint nothing but variable, which can be decision variables. The third is non-negative constraint or constraints. So how many constraints or variables you are taking, that should be always non-negative. Non-negative means either it can be positive or it can be 0, but it cannot be negative. But before coming to mathematical formulations, first you should know what is the meaning of objective function, what is the meaning of subjected to constraint, what is the meaning of non-negative constraints. See, let us say you're starting a business or anything you do, always you have some objective. An objective always highlighted in the above, the top. That is why the first step is objective functions. The objective function always expressed either in the form of maximum or in the form of minimum. It depends on the situation. As I said yesterday, always if you talk about the objective function, when it can be maximum, like the example last class I have given, production, sales, revenue, profit. In that cases, always the objective function will be maximum. But when the objective function will be minimum, like the factor given like cost, expenditure, time, in that case, objective function should be minimization form. So whatever you do or any are involved with any activities, always it is reflected in the objective. Now we'll see mathematically how the objective function is formulated. Now coming to produce this product, you may require employees, machineries, raw material, and many other constraints also you can take. But basically, you are taking 3-4 constraints like man, machine, material, methods, right? Money. These are some of these constraints. Like you should know how many constraints you have and what are the number of unit of the variable you have or constraint you have. Because that, looking that and taking that, you will achieve your objective functions. Like for example, you have let 10 permanent employees. By this you are achieving 500 unit of outputs. Well, if you feel that the demand is increasing, demand is like 550, you have a 10 number of employees. So here the question comes to your mind, how this objective will fulfill. When you have a 10 number of employees, but the target is you have to achieve 550 or let us say 600, but regularly you are producing 500 unit. In that case, so you have to go for optimum utilization of the. So there are different ways are there. The constraint can be used. Either go for utilizing this, whether in man or machineries, either optimum ways, or go for overtime calculations, or you have to purchase something more. But these are the constraints. Constraint is you have a 10 employees, 10 labor, but you want to achieve 600 or 550, but you are producing 500. See, this 50 unit or extra 100 units, how it can be possible? Because the constraint with you is manpower. We have a 10 number of unit of manpower. 10 laborers are there. We don't have much labor. And let in that area as labor is a problem. So labor sufficient not available. So looking all these constraints, whether it's a machinery constraint, you have a 3 number of machineries. By this 3 machinery, you are achieving 500 units of output regularly. Regular production depends on 3 units of machineries. But when the market demanding 600, what to do? So either you have to purchase more machinery or you have to go for overtime utilization. Again, if you go for overtime utilization, there may be a chance the machine may feel breakdown. Or if you purchase more machinery, again you have to pay something extra. Right? This is money is a constraint. The money or the capital you cannot expend more. So the money is a constraint, the machinery is a constraint. Sometimes raw material available is not sufficient in that area. Or market is demanding some more output like 600. Or 500 units, how much raw material required, that is there. But when the market demanding 600, you cannot deny. But the constraint is raw material. Raw material is not available sufficiently. What to do? So keeping all these constraints, so the raw material you talk about, machinery you talk about, methods or machineries or employees or employee or labor, whatever you can talk about. Looking all these constraints will try to achieve your objective functions. The next is non-negative constraints. Let me take an example. Again, the same example you can understand. Why it is called non-negative? I mean, why negative is not accepted? Because the number of unit of output you are getting, or the number of units of labor you are taking, the number of units of machinery you are taking, the number of machine or man, or you talk about raw material, the number of unit cannot be negative. Regularly you are producing 500 units, but if you market demanding 600 units, then in that case either you have to increase the number of labor, or you have to increase the number of machineries, you have to increase the number of material, or without increasing also, if you are achieving, that is okay. But if you are without increasing, if you are achieving it, then it is taken as 0. 0 means same value you are taking, you are not increasing or not decreasing. But if you feel that there is more requirement of raw material, there is more requirement of machineries, manpower, then you have to increase it. Increase means positive. But the unit values cannot be considered negative ways. Either you keep remain same, or you go for more, that is taken as 0, positive. So both you combine, that is called non-negative. Non-negative means the value should be always greater than or equal to 0. Either it should be 0, because if you talk about non-negative, it says always about 2 things. Either it should be positive or it should be 0. But negative is not accepted. So this is all about your objective functions subjected to constraint and about non-negative constraints. Let us see mathematically how to express it. As I said earlier, always objective function can be written in the form of either maximum z or minimum z is equal to cx. Now what does it mean? As you know, always the function expressed by y is equal to f of x. In place of y you have taken z. Then the question may countermand y maximum, y minimum. Because I said always objective function always highlighted in the 2 ways, either maximum ways or minimum ways. Then the question come to our mind, why did it be maximum, what will be minimum? The maximum, like if the question change about production, sales, revenue, profit. In that case, always it will be maximum z. The question arises, why it will be minimum? If the cost given, your time given, expenditure given, or diet like problems of taking doses of medicines, in that case always we talk about minimum z. So here we are expressing the form of a function, that is z is equal to cx. So c is the coefficient of x. So here c is the cost vector nothing but a matrix. So here we are multiplying 2 matrices, one is cost matrix with variable matrix. So x is called variable matrix, c is the cost matrix. If you multiply these two, what result will come? Now max or mean z is equal to c1 into x1 plus c2 x2 plus dotted cn xn. So you have written the format. Like if you have a 3 variable, you can move up to C1 x1 plus C2 x2 plus C3 x3. If you have 4 variable, let x1, I have written there variable matrix x is equal to x1 x2 xn. So if you have 3 variable, you take x1 x2 x3. If you have 5 variable, you take x1 to x5. When you have a 5 variable, of course there will be 5 cost values. The cost matrix always expressed in the form of row matrix. Your variable matrix or column matrix expressed by column matrix. A column matrix means one column having more than one row. Now, ultimately, if you multiply this C with X, C is a matrix, X is a matrix. C is a row matrix. Row matrix means single row with more number of columns. X is the column matrix, more row with single column. If you multiply these two, you know how to get matrix multiplication by your previous study. Otherwise, you follow previous books, because here you cannot express how to multiply two matrices. But you should know it. If you don't know how to multiply, you have to know it. When you multiply these two, you will be getting C1 x1, C plus C2 x2 plus that is C xn. So the example, once you get the example, or I will relate this theory, I mean this mathematical format to example by which you can understand better. Now coming to second part, subjected to constraint. I have written again two matrix multiplication. One is A into X less than equal to is equal to greater than equal to B. So here two matrices you have multiplied A with X. We are getting the output matrix, that is B. So what is A? Now is called coefficient matrix, which can be expressed like A11, A12 up to A1n. That is A21, A22 up to A2n. The last is AM1, AM2 up to AMn. I mean, the order of the matrix is M cross n. Similarly, the B matrix is a column matrix having the order M cross 1. There are M number of rows with 1 number of columns. And X is the variable matrix, because when the question asks solve the problems, solve means what? You are finding the value of the variable. So as per the variable given in the questions, that value has to be found out. And for example, you have a 3 variable, the question asks solve it, then you have to find out the value of x1, value of x2 and value of x3. We'll see later on, I mean in the coming slides. I hope this slide is clear. Now coming to what is x? X already have defined by the previous ones, still also have written there, x nothing but x1, x2 up to xn. Now if you multiply these two, A with x, what result you are getting? Right, you know A11 to Mn, and the order is M cross n. X order is n cross 1. So you are getting this way, A11 to x1 plus A1 to x2, because before that you should know how to multiply two matrices. Because there is a rule, two matrix multiplication possible. Let the first matrix A, second matrix is B. Then number of column of the first matrix should be equal with number of row of the second matrix. Then two matrix multiplication possible. Like for taking the first matrix is A, second matrix B, the number of column of the matrix A should be equal with number of rows of the second matrix B. Then once you cancel this number of column, number of rows, what resultant come? That is called resultant matrix order. Like here, you are getting the order is what? There are M cross 1. After multiplying A with X, you are getting M cross 1, because A11 x1 plus A1 to x2 up to A1 and xn is a single term, because you have added this, you have integrated this. I mean, this is the first position. Similarly, A21 x1 up to A2 and xn, the second values. I mean, a single column, these are first values, A11. This is 2-1 position, 3-1 position, last is M1 position. I mean, you can talk about a single value, single value present in one column. On the right hand side, you have written less than equal to, go to the previous slide, you can understand. You have written less than equal to, is equal to, greater than equal to B. What does it mean? Because its meaning is very simple. When you are writing, see, three things can be written. Either you can put the subject to constraint in the form of less than equal to, and when it is possible. Because in sometimes the notation may be even like at most, at least, exactly. Exactly means always you have to use the symbol is equal to. It is given at most. At most means a boundary. You cannot use beyond that, or you cannot use more than that. Then less than equal to symbol is used. But it is given at least, then you have to use greater than equal to the right hand side. Like the doctor suggests, you have to use at least 5 times in a day meditation. It shows greater than equal to 5. It doesn't mean that you can take more than that, you will be die. I mean, this is a meaning you should know. Right? At most means it is less than equal to, at least means greater than equal to, exactly means is equal to. This way you have to remember. So you have written Ax less than equal to is equal to greater than equal to B, but what is B? Now B1, B2, B3, Bm. These are the product matrix values or the resultant matrix values. So it has been compared. This value with the right hand side B1, second with B2, third is B3, last two is Bm. Now coming to the last one. Last one is called non-negative constraint. I said earlier, non-negative constraint means whatever the constraint or variable you are taking, always either should be positive or it should be 0. And I have given one example when it will be 0, when it will be positive. Like the example, previous example by the previous slide, I have told you, let any product you are producing in a day 500 units, but the market demanding 600 units. For this, let we are using 10 number of levers, 5 machineries. Let define by these two examples. I mean two constraints. One is 10 lever. It may contain male labor, woman labor, or skill or skill that you forget. At least the total number of labor is considered 10. You have a 5 machinery. By this you are achieving 500 unit of output. The market demanding 600. So what to do? Either you have to increase the number of machinery, or you have to keep remain same. You have to increase the number of labor, or you have to keep remain same. But if you are keeping any variable remain same, you have to write is equal to 0. When you are increasing it, that is greater than 0. That is why combining you have taken greater than equal to 0, non-negative. Non-negative means either it is positive, which is greater than 0, and 0 also exists. The xi greater than equal to 0 for all the values of I. So I varies from 1 to up to n. If you have 3 variable, you can go up to 1, 2, 3. If you have n number of variable, you can take 1, 2 up to n. Now there is one example by which you can be more clear. The example I have taken with production allocation problems. When the production things come to our mind, always we're thinking the quotient given maximization form or profit given maximization form. Let us read it, you can understand. If farm produces 3 products, product 1, 2, 3. These products are processed on 3 different machines, because any product you produce, of course, you require the help of machineries. And for this, the machine will take some time. The time required to manufacture the unit of each of the 3 products, and the daily capacity of the 3 machines are given in the table below. How many machines you have in the table? The 3 machinery, machine 1, machine 2, machine 3. How many products? Now product 1, 2, 3. So we have taken a matrix. Matrix means what? There is a link with row with column. And in the above, it is written time per unit in the form of minute. Like the product 1, they taking the help of machine 1, it is taking 2 minutes for 1 unit of product. Taking 4 minutes of the help of machine M2. See, product 1 taking the help of machine 1, help of machine 2, help of machine 3. Product 2 also taking the help of machine 1, but not taking the help of machine 2, but taking the help of machine 3. Product 3 taking the help of machine 1, machine 2, but not taking the machine of M3, I mean not taking the help of the machine M3. Again, each machine has some capacity. In a day, maximum it can use this much minute, which is given the right hand side of the table. Like in machine M1, it can be used for product 1, product 2, or a product 3, no problem. But keeping in mind that you cannot use more than 440 minutes. It is a capacity. The maximum capacity of the machine M1 is 440 minutes in a day. Similarly, machine 2 capacity is 470 minutes in a day. Machine 3 capacity is 430 minutes in a day. Now, looking this data, okay, the question is like this. Determine the daily number of units to be manufactured for each product The profit for each product of 1, 2, 3 is rupees 4, 3 and 6 respectively. I mean, you are getting profit from product 1 is rupees 4, profit from product 2 is rupees 3, profit from 1 unit of product 3 is rupees 6. So it is assumed that all the amounts produced are consumed in the market. So how much you produce, that can be consumed, that can be sold in the markets. So what you have to do is, you have to formulate the mathematical model. You have to formulate the mathematical model, I mean LP model, linear programming model, that will maximize the daily profit. Let me tell you, when you're talking linear programming problems, the first you should know what is linear programming. I mean, linear stands for, see, three terms are there. One is linear, one is programming, one is a problem. Linear means it is a linear equations. So how to define the linear equation? The equation is said to be linear if the highest power of the variable is 1. Then you can say it is linear equations. Doesn't matter, in fact, doesn't matter how many variables exist, but the highest power should be 1. The linear equation having 2 variables means both the variable having highest power is 1. Sometimes if the variable number are 3, but highest power is 1, so you can say again linear equations, but it is a multi variables exist. So from power identify the degree identify whether it is linear equation or quadratic or cubic. The highest power is 1, that is called linear equations. Now what is the requirement of this here? Now whatever the data is given, you have to convert all this data into linear form, linear equation form. The second question comes programming. Programming is nothing but planning, that is pre-planning. So you have to make a plan through linear equations. And the problem is you must have a solutions. Like you got 3 terms, one is linear programming problems. Linear means linear stands for linear equations, and all these data should be converted into linear equation form. Second is programming. Programming nothing but planning, that should be pre-planning. Third is problem, that means it must have a solutions. Now, in the question it is given, the profit for each one product is given. You are getting rupees 4 in the product 1, rupees 3 in the product 2, rupees 6 in the product 3 or 1 unit. So first of all, you have to formulate a model. Which I have told you in approach research, in theory, unless you are making a model, you cannot get a solutions. The theory is huge, but you have to convert it into mathematical model. Mathematical model says we have 3 steps. First is objective function, second is subjected to constraint, third is non-negative constraints. So you have to keep in this format. First should be objective function, which will be highlighted in the form of maximum or in the form of minimum. Second is subjected to constraint, third is non-negative constraint. This way you have to make an arrangement. But as I said, objective function always in this form, max star means. This way you have to arrange. Let us see. And we'll compare again how it has been arranged. So the question is, formulate the mathematical model that will maximize the daily profit. See, how to know the question is in objective function in maximum or minimum. So clearly in this question, it is asking about profit part. The concept is talks about profit. Profit means the objective directly be highlighted in the form of maximization form. So directly you can write here solution steps. See the last line of this slide. Max z is equal to 4x1 plus 3x2 plus 6x3 is not into this x. 4x1 plus 3x2 plus 6x3. So before, coming to theory, directly you can write this. So how? Because we will have a 3 product, we have to define 3 variables. One is x1, one is x2, one is x3. And always keep in mind, x1 should be linked with first product, x2 should be linked with second product, x3 should be linked with third product. That always you have to keep in mind. If there are 4 number of items, you have to take x4. Because always you are taking the variable x, y, z, something like that, w. But if you have a 10, 20 variables, then you will be it will be shortage to take from the alphabetic letters. That is why always when you have more than two variable, it is always better to take x1, x2, x3, x4, x5 onwards. By this, easily you can solve the problems. Here it is clearly written, let the extent of product 1, 2, 3 manufactured daily be x1, x2, x3 unit respectively. Means what? x1 is linked with product 1. The number of unit of product 1 is x1. Or sometimes you can write also, let x1 is equal to number of unit of product 1, x2 is equal to number of unit of product 2, x3 is equal to number of unit of product 3. What is the objective? You have to find out the value of x1, x2, x3. But here the question never asks solve it. Question asks just to form a model. Once you form a model, then automatically we solve by different methods. The method we will discuss on today. That is one method we will discuss on today. Next class we will see other methods. Now, coming to objective functions, as I said, it has to be highlighted in the form of max z. Why? Because the question talks about profit. But why for x1, why 3 x2, why 6 x3? Let me tell you, you can understand it. You are producing how much unit of product 1? x1 number of unit of product 1, x2 number of unit of product 2, x3 number of unit of product 3. But what is the profit is giving? 1 unit of product 1 is giving profit rupees 4. And if you are producing x1 number of unit, it becomes 4x1. Similarly, you are producing x2 number of unit of product 2. But what is the per unit product 2 profit giving? The rupees 3. So if you are producing x2 number of unit, it becomes 3x2. And what is the profit you are getting per 1 unit from product 3? The rupees 6. I mean, 1 unit of product 3 giving product profit rupees 6. And if you are producing x3 number of unit, obviously it will be 6x3. But any manufacturer or any producer, when it is involved with three variety production, like product 1, product 2, product 3, because always, as I said last class, the requirement of product diversifications. So, because all profit, the profit generated from variety product cannot be same. One may give good profit, other may give average profit, other may give less profit, but all has to be given to the customers. You cannot run with your business with only one type of varieties. So for this, when the manufacturer is producing 3 variety product, or the producer producing 3 variety product, that is expecting to have profit from 3. That is why it is 4x1. It is addition. 4x1 plus given, 3x2 plus given, then 6x3. Means you are producing x1 number of unit of product A, x2 number of unit of product B, x3 unit of product 3. That is why it is 4 into x1 plus 3 into x2 plus 6 into x3. This is the sum of the profit. Nothing but max z. Max z means what? You are trying to have more profit. Profit the given, but again we will be looking how it can be maximized. Now, the second part is subjected to constraint. Just a minute. Sorry. The second part is your subjected to constraint. The subjected to constraint will help you to achieve your objective. Here subjected to constraint are machineries. See the previous slide, you can understand. We have a 3 machine. Each machine has the constraint. First machine can max to max use for 440 minutes. It is 470 minutes. It is 430 minutes. You cannot use beyond that. How much time you are using for product 1, 2, 3 of machine number is up to you, but you cannot exceed 440 minutes. Similarly for M2, similarly for M3. Now, see the table again. In the table itself, product 1, product 2, product 3 are there. What you have done? You have linked x1 with product 1, you have linked x2 with product 2, we have linked x3 with product 3. So it will be like this: 2 into x1 plus 3 into x2 plus 2 into x3. 2, because if you look about machine M1, how much it is time is giving for product 1? Not 2 minutes. But we are defining number of unit for product 1 is x1, so 2x1 plus similarly 3x2, see by the wise, 3x2 plus 2x3, it will be less than equal to 440. The question arises, why less than equal to? Because the capacity of the machine given, you cannot use more than that. You cannot use more than 440 minutes. More than, I mean here at most 440 minutes you can use, at most, not more than that. That is why it is less than equal to. I have told you by previous slide, there is a given x less than equal to is equal to greater than equal to b. So 3 inequalities, I mean 2 inequalities, 1 equal symbol is there. 1 less than equal to, when it is capacities, at most, these are the symbols given, then you go for less than equal to. So in all these 3 lines you have to use less than equal to, because it is capacity given, machine capacities. Because if you use more than machine capacity, machine will feel breakdown. So you cannot use more than that capacities. So keeping in mind, it is like this: 2x1 plus 3x2 plus 2x3 less than equal to 440. Similarly 4x1 plus 0x2. Why 0x2? See this, because for product 2, machine 2 is not used. This value is given gap. Gap means you have to consider 0x2 dash. Dash means 0. The coefficient is 0. 0x2. Then 3x3 less than equal to 470. And the last is 2x1 plus 5x2. Here again for product 3 you are not using machine 3. That is again 0. Wherever the blank symbol given, dash symbol given, you have to behave this coefficient of the cost values are 0. So less than equal to 430. Now, if you consider this, just come to the previous slide, you can understand. When objective function are expressing by max z is equal to 4x1 plus 3x2 plus 6x3, I said to you, check. Given max or min z is equal to c1x1, c2x2, c3x3 up to cnxn. But in this question, you have a 3 variables. Why? Because 3 products are there. We have linked x1 with product 1, x2 with product 2, x3 with product 3. So the requirement is 3 cost. One is C1, C2, C3. But you have written there, what is C? The C is called cost vector or cost matrix, which is C1 up to Cn. But here you have to confine up to, I mean, in the row matrix you have to cover up to C3. Why? Because 3 costs are given, C1, C2, C3. Now here in this question, what is C1? Now C1 is 4, C2 is 3, and C3 is 6. Check. 4x1, 3x2, 6x3. So what is C1? 4. What is C2? 3. What is C3? 6. That has to put in a matrix whose name is capital C, because the name of the matrix always expressed by capital letters. And what is X? Now here there are 3 variables. So if you see the format again, check what is X I have written. Now x1, x2 up to xn, x1, x2, xn. But here you have a 3 variable, so you have to take x1, x2 up to x3. So this way it has taken. Similarly, as you know, always the subjected to constant taken as x less than is equal to, greater than equal to, is equal to b. But here all 3 are less than equal to. So this is not equation, this is called inequation. And you have taken in this way. So from this also you can derive your a, you can derive your x. Here what is a? Now is 2, 3, 2, 3, 2. Then 4, 0, 3, 2, 5, 0. What is B matrix? Now 440, 470, 430. The right hand side 3 values are there, but you know what is B. Now B1 to BM, see the last line. But here it will be B1, B2, B3. B1 means the last value, right hand side value, product values, product matrix values. So it is 440, 470, 430. Now coming to another example. So this example I hope clear. Have a similar example again. This example again talked about production, but again we're looking at the profit part. Now manufacturer manufactures two types of model A and B. Each, see the previous example taken product 1 and product 2, but here we are taking model A, model B. Each unit of the model are processed by two machines, that is by grinder and polisher machines. So the manufacturer has some grinder machines, some polisher machines. They have some restriction. Each unit of model A require 2 hours of grinding. In the previous case, what you have observed? The product A require machine 1, machine 2, machine 3. But here it again grinding, polishing. The name of the machine is specified. The model A require 2 hours of grinding, 3 hours of polishing. Whereas each unit of model B require 3 hours of grinding and 4 hours of polishing. But manufacturer has 2 grinder and 3 polisher machine. So how much time are using up to you? But it is having only 2 grinder, 3 polisher. That you have to keep in mind as a subjected to constraint. The capacity of each grinder and polisher machine is 40 hours and 60 hours respectively. But that is previous case it was daily, day wise. It is again the form of week wise. Now coming to second paragraph, the profit on each unit of model is rupees 7 and 9 respectively. So the benefit you are getting from model A is rupees 7 per unit. You are getting rupees 9 profit per 1 unit of model B. So what you have to do? Now you have to form a model, mathematical form of this above. Above means what the theory you have written, by which the total profit will be maximum in a week. Then the question comes to our mind, what you should write objective function, max Z or min Z. But clearly the last line written, the total profit will be maximum in a week. So you have to express the solution max Z. See in the middle it is written, objective function is max Z is equal to 7x1 plus 9x2. The question suddenly comes, how you know this 7x1, 9x2? See here, two type model given, model A, model B. The two variables we have to take, one is x1, one is x2. The x1 should be linked with model A, x2 should be linked with model B. Now how you write x1? The x1 is the number of unit of type model type A, x2 is the number of unit of model type B. Now what will be the objective functions? As you know, the profit is generated from 1 unit of model A is rupees 7 and the 1 unit of model B is rupees 9. But you are producing x1 number of unit of A, it will be 7x1. When you are producing x2 number of unit of B, it will be 9x2. But the manufacturer is getting profit from both. So on integrating, what you are getting? 7x1 plus 9x2. 7x1 plus 9x2. And y maximum Z profit given. Now coming to subjected to constraint. As you know, we have a two machine, grinder machine, we have a polisher machines, and the model we have a model A, model B. I have kept in the bracket hour. With the model A, when you are going to produce or manufacture by the help of a grinder or polisher, it takes some time in the form of hour. And again, I have kept x1 because x1 is linked with model A, x2 is linked with model B. Again, the capacity given. You cannot go beyond the capacity. 2 into 40 is 80. What is the meaning of this? Now see, the manufacturer has two grinder machines. Each grinder can work for 40 hours in a week. When you have a two grinder machine, the max to max you can use 80 hours. 2 into 40 is 80 hours. Similarly, the manufacturer has 3 polisher machines. Each polisher machine can work for 60 hours in a week. But we have 3 polisher machine. The maximum time available is 3 into 60 is equal to 180 minutes. Now this has to be converted into inequation form. How? Now 2x1, why 2x1? The grinder, when you are using for model A, it is taking 2 hours. That is 2 into x1 plus 3 into x2 it should be less than equal to 80. Let us see. The second one is 3x1 plus 4x2 less than equal to 180. In the previous example, I have given idea clearly how it will be. That is why I have written directly 2x1 plus 3x2 row wise look 2x1 plus 3x2 less than equal to 80. Why? Capacity return. You cannot use bend the capacity. Bend the capacity if you go for the machine will breakdown. Or if the employer involved, you are using the overtime inflation, but you are not paying extra, there may be a chance they will leave the organizations. Okay. The third is non-negative constraint. How many variables you are using? Here you are using two variables, x1, x2. So it is greater than equal to 0 because decision variable or the constraint cannot be negative. It is either positive or it is 0. Why? Because if you are keeping remain same, it is 0. If you are using more than that, it is always equal to, greater than 0. Just a minute. A similar example given, like this is one of the example where in the form of minimization. Let us see. A company has two grades of inspector, inspector 1, inspector 2, grade inspector 1 to undertake quality control inspection. At least, see the term, at least means what? Greater than equal, as I said earlier. 1,500 pieces must be inspected in an 8-hour day. I mean, the inspector has to, because the role of the inspector is they have to inspect in 8 hours. But there is a constraint. Grade 1 inspector can check 20 pieces in an hour. In 1 hour, he can inspect only 20 pieces. With an accuracy of 96%, you cannot say 100% it is accurate. 90% chance that it will be accurate, 4% chance that error exists or inaccurate. Similarly, grade 2 inspector checks 14 pieces in an hour with an accuracy of 92%. I mean, 80% is error. Now, what the wages we are paying? The wages for grade 1 inspector is rupees 5 per hour, while those of grade 2 inspector is rupees 4 per hour. So any error made by an inspector costs rupees 3 to the company. If there are in all 10 grade of 1 inspector, 15 grade 2 inspector in the company, to find the optimal assignment of the inspector by which that minimizes the daily inspection cost. So clearly it is written minimization form. The certainly come to the mind, what will be the objective functions? It is given out to cost factors, so always it will be minimized there. But always you have to define what is x1, x2. But why you take x1, x2? Because you have a 2 grade of inspector, inspector 1 and inspector 2. The discussion is all about grade 1 inspector, grade 2 inspector. To try to link two variables x1, x2, the x1 has to be linked with grade 1 inspector, x2 should be linked with grade 2 inspector. Or else you can take xy also. Because here only require 2 variables, either you can take xy. But the moment you are getting 3-4 variables, always it is better to take x1, x2, x3, x4 like this. So the objective is to minimize the daily cost of inspection. Because the spending for this, the spending amounts always should be minimum. The company has to incur two types of cost, wages paid to the inspector and the cost for the inspection error. Now, first of all, you have to find out the cost of grade 1 inspector is per hour is rupees 5 into, so say 5 plus 3 into 0.04 into 20, which is rupees 7.40. How it is? Let us see, you can understand. When the grade 1 inspector accuracy 96% is, because you have seen by this slide, always cost is calculated by using 2. One is wages paid plus for error, the cost of the inspection error. So wages plus wages paid plus inspection error cost both has to be added. That is why the wages we are paying rupees 5, it is clearly given. You can check in the second paragraph. Wages we are paying for grade 1 inspector is rupees 5. So 5 plus the second is what? Error cost 3 into 0.04 into 20. Why? Let us check. Why it is 3? Because any error made by an inspector, you have to pay rupees 3 to the company. So rupees plus 3 into error made by grade 1 inspector is 4%. 4% is 0.04. Check. 0.04 into 20. Why 20? Check. The grade 1 inspector can check 20 pieces because he can check only 20, not more than that or less than that. So 20 has to be multiplied. So that is why it is 3 into 0.04 into 20. Finally, you got rupees 7.40. What is that? The cost of grade 1 inspector per hour. This amount, where it involves the wages plus the common error charges to the companies into the error percentage. It is having the grade 1 inspector having 4%, and it can check 20 pieces 20. Similar ways, the grade 2 inspector value can be found out like rupees 7.36. The objective function will be minimized. Z is equal to 8 into, because as you know, we have linked x1 with grade 1 inspector, x2 with grade 2 inspector. To see the bracket value, 7.440 or 7.4, 7 with 30 paise into x1 plus 7 into 7.36, 7 rupees 36 paise into x2. But outside the bracket 8 written. Why 8? Because it is the value you have found out for 1 hour. But it is given clearly, inspected 8-hour day. In one day you are working for 8 hours. So for 1 hour data once you got, then 8 has to be multiplied because you are looking for 8 hours. So finally you got 59.20 x1 plus 58.88 x2. Now coming to constraint, this is objective function over. Coming to constraints, we have two constraints, x1, x2, x1 linked with the grade 1, x2 linked with the grade 2. So it is clearly written x1 less than equal to 10. Why check? It is clearly 10 grade 1 inspector. We have a not more than 10 number of grade 1 inspector. So how much unit you are finding is okay, but it should be less than equal to 10. But again, question comes to your mind, x1 greater than equal to 0. It's okay, no problem. Greater than equal to 0, but less than equal to 10. All the values are positive. So x1 less than equal to 10. Similarly, the number of grade 2 inspector available is 15. Available means what? Maximum. You cannot go beyond this. So x2 less than equal to 15. So there is some other constraint we have. So the number of pieces to be inspected daily, because the grade 1 inspector regularly checking 20 units, grade 2 inspector regularly checking 14 units. But the maximum, at least how much they have to check? At least 1500 pieces must be inspected in 8 hours. So both will inspect, but the maximum, at least they have to inspect 1500 unit pieces. They can check more than that, but they should not check less than 1500. That is why it is written 20 into 8x1 plus 14 into 8x2 greater than equal to 1500. Why greater than equal to? At least. Multiply this two, you will get 160x1, or it means implies 160x1 plus 112x2 greater than equal to 1500. The last line is non-negative part, x1 comma x2 greater than equal to 0. Why? Where x1 means what? Number of unit of grade 1 inspector. x2 is the number of unit of grade 2 inspector. The number of unit cannot be negative. Either you are taking more positive, you are not taking more. Now let us come to solution. Solve LPP, you have many more methods like graphical method, simplex method, revised simplex method, dualities, basic feasible solution methods. Many more methods exist. But simpler ways, if you see, you have a two method. One is a graphic method, one is simplex method. The graphic method has some constraints. The graphic method always says coordinate axis. Coordinate axis always says about two axes. One is x axis, one is y axis. So in x axis you can take x1, x nothing but x1, x2 nothing but y. But when you have a more than two variable, then graphic method fails. In the graphic method, when you have a max to max two variable, you can talk about graphic methods. But more than two variable, always remember it. The limitation of graphic method is graphic method fails when the LPP or linear programming problem contains more than two variables. So that is something written. So always listen variable x, if x1, x2 given, the x1 you take in x-axis, x2 you take in y-axis. What are the steps for solving LPP by graph methods? So always whatever the problems comes, first you formulate the LPP by writing the objective function we have seen by previously, either in form of maximize or in the form of minimize. Maximize talks about profit, minimize talks about cost of production like this. Then constraints. Constraints are changed into inequalities because constraint always given the form of inequalities. See the previous example. See this constraints less than equal to 80, less than equal to 180. So that has to be converted to equalities. Because if you consider about graph methods, this heading written steps for solving LPP by graph methods. Graph methods, it is very sure that we are going to take two variable. If two variable exist, let us see how the graph method can be used. So first of all, you have to check whether the LPP or not. How to know? If three steps are exist, like objective function is given, subjected to constraint is given, non-negative constraint given, then you can understand LPP. It is LPP. Once it is LPP and that too, there are two constraints exist, then you think about graphic methods. The graphic method, what to do first? First, you convert all the constraint into equality form. Because the constraint always in the form of inequalities or inequation. So first you have to convert it into equation form or equalities form. Just you have to write there, convert all the inequalities to equalities, we get whatever inequation given, directly put the equal symbol. Just replace by equal symbol. Then all this constraint you have to plot on a graph. You have to identify feasible region. Feasible region means the region which is the common portion for all the inequalities, right? Then by that region we will be getting a number of coordinates like number of vertices or corner points. Once you got feasible region, once you got number of vertices, in each vertices value has to be found out. That will be put in the objective function. If the question given maximum, which one maximum, that is answer. The question given minimum, which one minimum, that is answer. Let us see some example. This is a question. That is one question given, maximize z is equal to 50x1 plus 60x2. Here two variables exist, one is x1, x2. These are the subjected to constraint where all these constraints are given the form of less than equal to. So first what to do? See the last line written, at first you have to write directly 2x1 plus x2 is equal to 300. The question come to your mind, why it is equal to or how it has come. And directly whatever the inequality symbol given, you write the equal symbol. Because unless you are making it equal, you cannot form the points. Unless you are forming minimum 2 points, you cannot draw lines. So like this, if I take x1 0, by default x2 will be 300. So 1 point you got 0, 300. If you put x2 0, 2x1 is 300, x1 is 300 by 2, which is 150. What is the point you got? 150 0. Because always in the point x1 will come first, x2 comes later. Now taking this 2 point, you have got this figure. Right? And one thing remember, when any equality given less than equal to something, always the points are taken towards origin. If you greater than equal to given, then the points are taken away from origin. If is equal to something given, then that is, it shows the points are taken on the line. Here you have a 3 constraint, 2x1 plus x2 less than equal to 300, 3x1 plus 4x2 less than equal to 509, 4x1 plus 7x2 less than equal to 812. So all these 3 inequalities are less than equal to. So first you are taking one by one will take, then finally we will merge it. The first is what? 2x1 plus x2 less than equal to 300. This figure you have taken. This is the line you got. By taking this point, this 2 point, to join this 2 point like 0, 300, 150, 0. How to take in the graph paper? Now you have to write the graph above. In x1 axis, 1 centimeter is equal this much unit. In x2 axis, you have to mention there. Then as for your requirement, the unit has to be taken. This figure got like this. But why this is the region? Now the points are taken from this line towards origin, because always you know in coordinate axis we have a 4 quadrant: first quadrant, second quadrant, third quadrant, fourth quadrant. And always the points are taken in the first quadrant. Why? Where the value of x1 and x2 both are positive or 0. And in non-negative constant always says the value should be either positive or 0. It cannot be negative. That is why from this line towards origin means this is the portion you got. Similarly, coming to second, third, you'll be getting like this. Now all the three if you merge, you'll be getting this type of figures. And all this, origin is origin means what? Where two axes cross each other, all are moving towards origin. Feasible region says find out the common portion who is satisfied to all the inequalities. So this shadowed portion is the common portion for all the inequalities. You can verify because this portion coming under all the inequalities. So here you got how many vertices? Now one is origin. 1, 2, 3, 4. 4 vertices you got. Sorry, 1, 2, 3, 4, 5 vertices you got. The names are given A, B, C, D, E, F, G, H. Sorry, one is A, B. Okay. The standard portion, we have a 1, 2, 3, 4, 5 vertices. 5 vertices value you have to find out, right? Five vertices value you have to find out. This is one of the example. It has not found out. Just I have shown how to take the figures. Then, as per the question, you have to put the values. If at any point the value is maximum, that is taken. The question is given minimum at the point where the minimum taken. So, for example, exact example can understand. The maximization problems, same way it is given. So, first of all, x1 less than equal to 20,000 it is given, x2 less than equal to 40,000 given. So first you make it equal. By which you get two lines, one is x1 is equal to 20,000, x2 is equal to 40,000. The third constant is 0.003 x1 plus 0.001 x2 less than equal to 66. Here 1 x1 you take 0, x2 value will come out. Once you take x2 is equal to 0, x1 will come out. By this, these are 4 points you got. So, similar last one is x1 plus x2 less than equal to 45,000. Again, take x1 0, x2 will be 45,000, take x2 0, x1 will be 45,000. Like this, if you convert, this figure will come. This figure come. Again, you have to check all are given less than equal to the towards origin. Towards origin means this is the particular portion will come. Like the points are O, A, B, C, D, E. O is the origin, then A, B, C, D, E. How many points? 1, 2, 3, 4, 5, 6. 6 vertices. 6 vertices value you have to find out. Check how it is. Origin always 0. A point value is 0, 40,000. The value you have taken, because check. A value is, when you have taken point A, it is at 40 place with 0, because is 1000 unit you have taken in axis. So 0, 40,000. B value is 5,000. 40,000, C value is 10,500, 34,500. Now all this point value put in objective function. What is the objective function? The objective function is max z is equal to 2.80 x1 plus 2.2 x2. Now whatever the x1, x2 value got, that for each point that has to be put in the objective function. After putting this, you got the value of z at A is 88,000. Then at B is 1,02,000, 1,05,300, 69,200, 56,000. Now which one maximum? 1,05,300 maximum. What is the question? The max Z. The question asks about max Z. Now the value of Z, different point you got different values. Now out of this, you got the maximum value is 1,05,300, which has a link with point C. I mean, you have to write the value of the objective function is maximum at the point C, which is 1,05,300, where the x1 value is 10,500, x2 value is 34,500. Similarly, there is another question given minimization form. Same way you have to do, but here it is given greater than equal to form. So always take an hour from origin. So this is a question. So this way, again, you have to take the points, but here you have to look, check. Here at the point O, the value of Z is 0. At the point A value, the value is 720. At the point B, the value of Z is 280. At the point C, the value is 160. Now which one minimum? Not C. Same thing, all right. The value of Z is minimum at the point C, where x1 is 4, x2 is 2, and the optimum value of Z is 160. Similar, some more examples are there. We can go for some exercise. You can do some example from your book or any operation results you follow. The same way if you solve, you can get maximum values, you can get minimum values. Thank you.